Okay, so I told you before we're recording in class today. So make sure I let you know. Okay, so first we're going to name ionic compounds. We have ionic compounds and covalent compounds we're going to name. We're going to start with ionic. But before you can name an ionic compound, you have to know if it is an ionic compound. So how do you know if you have an ionic compound? First, you need a metal. You need an element on that left side of the periodic table. Oh, you have a metal. Metals always come first on the periodic table. They come first in your compounds. The metals are your cations. So the metals are your cations. They are your positive charged ions. Okay? The first element must be a metal for it to be an ionic compound. So far, so good. Cations will keep their original names. So sodium stays sodium. Chromium stays chromium. Manganese stays manganese. You do nothing to their names. The first name just is the same way it is on the periodic table. Okay? Cations keep their original names. Metals form cations and always come first in the compound. Probably should put that down. They always come first in the compound. Always, always. Does that make sense? Yes? And again, my metals are on the left-hand side of the periodic table. The first element for an ionic compound has to be a metal. The second element has to be a nonmetal. Okay? That's how you know it's ionic. So anions are going to change their endings to IDE. So these nonmetals on the right-hand side of the periodic table will change the endings to IDE. That's what anions do, the negatively charged nonmetals. Chlorine becomes chloride. Oxygen becomes oxide. Nitrogen becomes nitride. Fluorine becomes fluoride. They're all pretty straightforward. There's some really strange ones though. Well, carbon becomes carbide. If hydrogen is the second element in an ionic compound, it becomes hydride. Selenium becomes selenide. Silicon becomes silicide. Okay? And I will give you some leeway on these. Okay? I'll give you a little, time for knowing how to do these. So, we'll practice. But nonmetals form the anions. They always come second in the compound. Metals, then nonmetals. It's alphabetical. Metals, non. Metals, non. Metals, non. Metals come first. Always. Okay? Now, there are two types of ionic compounds we're going to talk about. Type 1 binary ionic compounds. I would strongly suggest you write this down. You will need to know these. Type 1 binary ionic compounds. Now I'm going to go through and tell you what these all mean. Now type 1 are also called monoatomic for this reason. Type 1 means the metal has only one possible charge. Just like that worksheet you did over the weekend. That's why I had you look up the charges. It only has one possible charge. Okay? So if you look over here, calcium, if you look on your periodic table, has a +2 charge. That's only one possible charge. So this is a type 1 metal. Silver only has one possible charge, +1. Type 1 metal. Zinc has only one possible charge. It's a type 1 metal. If it has more than one possible charge, it's a type 2. Binary, what do you think binary means? 2. There's only 2 elements in your compound. Look for 2 capital letters. There's only 2 elements in your compound. That's what binary means. Bi means 2 elements in the compound. An ionic compound has to have what 2 elements in it?
Cation and anion.
Cation and anion. And all cations are represented by what type of element? Metals. So we have a metal and a nonmetal. The compound contains only a metal and a nonmetal, or a cation and an anion. And the metal is always written first in the compound. Does that make sense? Yes? No? We okay? Okay. A few more minutes to write these things down.
Just like a metal and non-metal with one charge, it's just a compound.
The type 1 binary ionic compound. Yes? Okay, so if you look at your periodic table, you should have it in front of you right now. If you look at aluminum has a 3 charge. It's +3. I just didn't put the pluses on there. That's a type 1 charge. There's only one possible charge it can have. Does that make sense? Okay.
What is plus or minus?
If it's a plus or minus, it can go either way. Like carbon is a plus or minus 4. It can act as a cation sometimes, like CCl4. We call it carbon, it goes first. If it's second, if it reacts with a metal like sodium, then it's sodium carbide. So it can go either way.
So that wouldn't be a type 1 if it's plus or minus?
Typically, no. Your nonmetals are going to be a type 3, something else. Now, let me give you a flow chart here. This will help you work your way through all this. Okay? So whenever you come in for the next week and a half, I want you to get out your periodic tables, get out these flow charts, okay? And make sure that we're using all the possible tools we can use. These are all in the toolbox in Schoology. Okay? Does everyone have one now?
No.
Okay, then you come back. Ran out. Oh no. There you guys go. Now, to make this a little easier as well, I've done something else. But you'll ask yourself these series of questions when I do this sort of thing. So, you start at the top. So we have this compound right here, CaCl2. First question, is the cation hydrogen? What's my cation in this? Calcium. The first element, your cation, correct? Yes? So is it hydrogen? No. So we go down. Is it? No. Is it binary? Is that a binary compound? Yes. So we say yes it is. Is there a metal present here? Yes. So yep. Yes it is. Does the metal have more than one charge? Calcium. Everyone look at calcium. What charge is on calcium? Everyone touch calcium on the periodic table. Let me walk around and see. Show me where calcium is. Okay. Okay. See how it has only one possible charge?
Yeah.
That means,
Only one possible.
yeah, like that has more than one. That won't be a type 1.
Okay.
Okay? You need to use this. This is not time to be guessing. Do not guess and say yes or no or whatever. I want you to look this up every time. Excellent. Thank you, thank you, thank you. No, not this periodic table. It has to be the one with all the charges and stuff on it. So it has to be that one out. This is not really helpful. Okay? If you need another one, let me know because I have plenty of them. But make sure, I would stick it here in the front of your binder. Okay? Everyone have it out? Good. And then, no, so it's a type 1. Now what I've done to help you is this. on your PowerPoint, which you can find in Schoology, is this. Naming compounds PowerPoint. I need everyone looking, please. Not me, up front. Click on this. It's going to take you to a PowerPoint. Another PowerPoint. Okay? Now, to make this work, you have to present this. So go under View when it comes up. Oh, it's here. It's already up on this one, I think. I lied. So go under View and hit Present. Because you need it to be in presentation form to be able to use it. Okay? So, it's naming compounds. So you click on it. So for calcium and chlorine, CaCl2, was the first element hydrogen? No. Click on no. It's going to take you through the whole series of questions. Is a compound binary? CaCl2? Yes. Is the first element a metal? Yes. Then it says, okay, since the first element's a metal, ask yourself, how many possible charges can the metal have? Only one charge or more than one charge? Only one. So then you go here and it tells you how to name it if you have forgotten. Okay? So you name the cation first, write it just the way it is on the periodic table. Now, to name the anion, you have to change the ending to IDE. So if it's MgCl2, it's magnesium chloride. Does that make sense? Then go back to the home and it takes you back to the first slide again. You can do this for all of them. Now, if it's not hydrogen and it's not binary, it's going to take you a different way. And it's going to show you how to name those as well. So this will be for all the different compounds we're going to come up with. Now, you will not have this on your test. Okay? So make sure that you know how to do this. I'll let you use that flow chart for a while. But you have to know how to name these because this takes us into reactions. And you got to be able to name them like this. Okay? You good? Yes. Okay. So now what we're going to do, we're going to start naming them. And I'm going to see real quick. Now if you want to, don't write the stuff down. But if you need to down the road, you can easily go through and it'll walk you through how to name these. That's what the PowerPoint will do. Okay? Yes? But I choose not to do that right now. I choose to show you actually how to write these. Okay? So let me see if I can put this someplace. Miss Brozart and I decided we're going to call this Swally. Like Wally the robot, but it's a swivel. So it's Swally instead of Wally. So, because she's going to start using it too. So, yay. That'll be fun. Okay, so, little Swally here. Okay, so now what we're going to do, first we're going to write formulas. So you need to write this stuff down, please. So, writing type 1, whoops, formulas. Okie doke. So let's say I have aluminum nitride. To write the formula, what is the symbol for aluminum? Al. Look at you guys. Good job. Al. And what is the symbol for nitrogen, which is nitride? N. So you write down your symbols. Then let's write down our charges. What's the charge on aluminum? +3. And what's the charge for nitrogen? -3. And then, here's what we do. We just crisscross the charges. This 3 comes down here, we drop the charges when they come down, and this 3 comes down here. So our formula is going to be Al3N3. We just brought the charges down. I'm sorry? No plus or minus, because this is, remember, this is a count. It tells me I got 3 aluminums and 3 nitrogens, right? The count can't be negative, can it? So the charges can be negative and positive, but the count, the subscripts cannot be. But can I reduce this to lower terms? So it's going to become what? ALN. I divide each of these by 3, and I get a 1-to-1 ratio, don't I? We'll do a few more of these, so if you don't get it right away, that's okay.
On the test, do we have to like simplify
Reduce?
it? Yeah.
Yes. You must simplify always.
You have to write the one.
No, you do not have to write the ones. I'm just doing that now just for good measure, but you do not have to. So far, so good? Brett, is there a question? Okay. So let's do another one. Let me get out my paper towel here. So, what if we have silver sulfide? What is silver's symbol? Ag. Well, good job. And what's sulfur symbol? S. Good. Now let's write the charges. What's silver's charge? +1. Well done. And what is sulfur's charge? -2. Does everyone see where we're getting these numbers from? Your periodic table? You need your periodic table out in front of you. I did not get you one, did I, Kyle? And make sure you put this in the front so you always have it, okay? There you go. So, silver sulfide. And then what's my formula going to be? What do you think, Haley? What am I going to do with those charges? Crisscross them, and my formula is going to be what? Well, give me say AG. Perfect. AG2S1. Well done. Good job. Does that make sense? Yes? You good? Yeah, they're pretty simple. Writing formulas is really easy because it's right there. Okie doke. Well then, okay, Mason, with us. Now we're going to name them. This is where the flow chart comes into play. Flow charts are for naming only. Okay? So let's say we have, let's see. Whoop, get backwards. There you go. So the first question you ask yourself, is hydrogen the first element? Nope. Is it binary? Yes. Is the first element a metal? Yes, it is. Does the metal have more than one charge? No, it does not. What is the charge on zinc? +2. It's got to be a +2. Okay, make sure charges always have some like plus or minus in front of them. Okay, and phosphorus is -3. You really don't have to do this part. I just kind of did it to show you. But if it is a type 1 metal, there's only one possible charge. You just name it as you see it. So what is Zn? Zinc. And P is phosphide. Good job. OSPHIDE. That's zinc phosphide. Well done. Does that make sense? Yes? Okay. Let's do another one. Let's do BAO. So is the first element hydrogen? Nope. Is it binary? Yep. Is the first element a metal? Yes. So does the metal have more than one charge? Nope. So you just name it as you see it. What's Ba? Barium, and O is? So it's barium oxide. Pretty straightforward. Does that make sense? How we feel about those? Good? Yes? Kind of give me a, we're okay moving forward? Okay. Type 1s are very easy to name and do. But you have to recognize, here's the thing. You have to recognize it is a type 1 metal. You got to look it up. It is a metal, and there's only one possible charge. Okay? Yes? So it takes some work. You have to look all these things up. Okay. So now let's talk about type 2. Type 2 compounds. Make sure that's where it belongs. There we go. Okay. So now type 2 binary ionic compounds. Make sure you write that down. Type 2 binary ionic compounds. Now, type 1 only has one possible charge. What do you think type 2 is going to be? It has two or more than one possible charge, right? So type 2 means the metal has more than one possible charge. The metal has more than one possible charge. And what I'm going to do right now, I'm going to ask you to highlight your periodic table, all the elements, little boxes that have more than one charge. So get out a highlighter, and if the element has more than one charge, I want you to highlight it. Okay? Who needs a highlighter? Oh, yeah, it works. So there you go. 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 Whoop, that's not one. And who else needs one? There you guys go. You guys need highlighters? There you go. So let's take a minute. Let's highlight. Oh, I miss you. Oh, that's good.
Would carbon be more than one?
The carbon's not a metal. It has to be a metal. Yeah, it has to be a metal with more than one charge. That's an excellent question. And don't forget about the intertransition metals also. Sorry? Of course you may have a new table. I have lots and lots and lots and lots of periodic tables. There you go. So go ahead and
Are we only highlighting the metals?
yeah, because when
none
it's
of
type
those?
1 or type 2, you have to look at the metals only. Because these are all my nonmetals. I don't worry about the nonmetals. Just the metals determine how I name it. Okay, where's your periodic table, Mason? I need you to get it out then, please. It has to be out every day. And I'd like you to highlight it as well. Guys, binders really help at this point in the game. Okay? I've asked you at binders the first day of school, and I see a lot of people who don't have just a chemistry binder. You need a binder just for chemistry. or a folder of some sort, because you cannot throw every other, that's how you study. You need to be able to study from one binder only. So I'm going to kind of challenge you guys to do that if you can. One binder for chemistry. Okay, a few more minutes, then we'll. Just reading in the middle. Nice. Much better. Do you mean me get rid of this?
Yeah.
Okay. I'll be glad to recycle it for you. Yes. Who said that? This JD girl. I'll recycle that for you then. How about that?
Thank you.
Up. And out of the lines. I do the same thing though. It would drive me crazy. That's why I hate doing art stuff. And when you're done, if you just kind of give me my highlighters back, that'd be lovely.
This one's out.
Oh, there you go. Look at that.
Yeah.
Sharing. So wonderful. Sharing is caring. Yes, ma'am. Yeah, make sure you sign out there, okay? Where you're going. Did you get them all down?
Mm-hmm.
Make sure you get these ones down here as well. This will help you so when you see a highlighted element, you know it's going to be a type 2 right away. You don't have to go hunting for everything. Okay? A few more minutes. Some of these are so pretty. Wow. These are just a good way for you to quickly say, hey, that's a type 2. It's going to need Roman numerals. Okay, so let's move forward. So type 2 means it has more than one charge, and maybe right under there, it's highlighted. So on your periodic table, you know this thing's going to be highlighted. What's binary mean again?
2.
Has 2 what? Elements. Has 2 elements in the compound. So that compound has 2 capital letters, 2 elements. Ionic means what? What 2 things does the ionic compound have to have? A cation and an anion, or what else, Aaron? Metal and nonmetal. It has to have a metal and a nonmetal. So type 1s, the metal only has 1 charge. Type 2, the metal has more than 1 charge. Does that make sense? Yes, no, possibly, maybe? Yes, okay, good. Good. May I move forward? No? Oh, Jade's back there highlighting still. Well, fortunately, you can do that a little bit later because you know what to do with it. You're going to have some time a little bit later to do that if you want. Okay? So, if you look at those ions that we're talking about, the ones that are type 2, most of them are in the transition metals, aren't they? The transitions or the inner transitions, that's just typically where they fall. Because that whole D block, the D suborbital, has a very odd effect on these metals. And don't worry about writing these things down. It's something we just said. Basically, there's more than 1 charge. So don't write these 2 points down. Don't worry about it. But the transition metals are the ones typically that have more than 1 charge. Okay? If you look on your periodic table, vanadium has 2, 3, 4, and 5. That's a type 2 metal. So it has more than one charge. It is a type 2 metal. Okay? Yes? So far, so good. Okay, now back to the teaching. To instructing. Okay, so, come here, Swally. Let's go back over here again. So you can see, I want to make sure everything's in the way. Okay. Now, you guys know your Roman numerals?
Barely.
Okay, well then let's review Roman numerals then, shall we? Okay, so we just use lines. So 1 is just one line. 2 is 2 lines. So 1, 2. 3 is 3 lines. I would write these down if you don't know them. 4 is 1 line and a V. Well, thank you, Brett. 5 is a V. 6 is a V1. 7 is a V11. And 8, which we probably never get to, is a V111. So 1, 2, 3, 4, 5, 6, 7, and 8. You need to be able to know these and write these down. We use Roman numerals with type 2 metals. So make sure these are all written down. So far, so good? Yep. Okay. Now, why do we use Roman numerals? We use Roman numerals because we have to tell the reader which charge we're using. Just like this. If I leave Ross and I went ahead to Hamilton, and my road looked like this, and Hamilton is here, do I have to give them any instruction? I leave school and just go left and keep going to Hamilton. But what if I left school and the road looked like this? Which actually it does look like this, kind of. And this one goes to Hamilton, and this one goes to Oxford. How would you tell that person to go to get to Hamilton? Stay to the right at the fork, right? You've got to tell that driver which way to go, because there's 2 choices that you could go to, right? If you don't tell him go to the right, the car is going to get right here and go, crud. Which way do I go? There's no sign. So you got a 50-50 chance of doing this incorrectly, right? So you need to tell the driver which way to go. For your type 2 metals, you need to tell the reader which way you're going. We're going to start first with writing formulas. Writing formulas is always much easier. Okay? So, here's a compound, a type 2 compound. So, let's say we have gold, 3 chloride. Gold 3 chloride. You're like, why would you put that Roman numeral in there? That Roman numeral, if you look up gold, what are the charges on gold? +1 and +3. This number, this Roman numeral right here, tells us which one of those 2 I'm using. This is going to be gold +3. Does that make sense? That Roman numeral tells us the charge on the metal. Yes? And then chlorine has what charge on it? -1. Is there more than one charge for the nonmetals? No, there's not. So there's no need to put a Roman numeral for the nonmetals. There's only one possible way you can go. Correct? So then I crisscross my charges. 3 comes down there. The 1 goes there. And it's AuCl3. So far, so good. How are we doing? Talk to me. Okay. How about another one? How about lead 2 sulfide? What's lead symbol? PB, sorry, yeah, PB. And what's the charge going to be on lead? +2, right here. See this? You don't even have to look it up. It tells you what it is, doesn't it? So +2. And what's sulfur's symbol? S. And what's sulfur's charge? -2. So I crisscross my charges. This 2 comes down here. That 2 goes over there. So it's PB2, S2. Can I reduce it at all? And what's my formula going to be? PB1, S1. Or just PBS. PBS, yep. Does that make sense? Pretty straightforward, yes? Yeah, we okay? Okay. So now, let's go one step further. Now let's name them. Naming is a little more difficult than writing formulas. So let's say I have, let's see, ask yourself the first question. Is the first element hydrogen? No. Is this binary? Yes. Is the first element a metal? Yes. Does the metal have more than one possible charge?
Yes.
Yes. And what are they? +1 and 2. Okay? What is chlorine's charge? -1. Now here's the all-important question I'm going to ask you. I need you listening. Does this 1 here match this number down there? Remember we dropped the charges. I'm not saying there's a charge match, but does the number match? If there's no number there, what's that number? 1. Does this 1 up here match that 1 down there? Yes. If the numbers are the same, then whatever number is over here is what we are going to use over there. You're crisscrossing backwards. Remember you brought them down for the formula? Now we're just going back up. Does that make sense? So this is going to be copper 2 chloride. We're using the +2. Does that make sense?
If the numbers match, you use the 2?
If the numbers match, these 2 match, then whatever's down here is what you use.
What if they don't match?
We're going to get there. That's a great question. We're going to get there. Okay? Let's try another one, shall we? So, let's say we have, I'm terrible at these. Let me look it up. Whoop. Swallow, you stay over there. So, let's say we have chromium. Let's see. Okay. Say we have that. Oop. Is the first element hydrogen? No. Is it binary?
Yeah.
Yes. Is the first element a metal?
Yeah.
Yes. Does the metal have more than one charge? And what are chromium's possible charges?
+2, 3, and 6.
2, 3, and 6. Perfect. Then what is sulfur's charge?
-2.
-2. Does this number match this number down here?
Yeah.
Yes. So which of these 3 am I going to choose? The 3. Because that 3 matches that 3. Yes? So this is chromium. 1, 2, 3, sulfide. I have to use a 3 because I have to tell which charge I'm using. Does that make sense? Now let me show you something. So if I have Fe2O3, that's a name for that. So, I'm sorry. So, is it first element hydrogen? Nope. It's first element. Is it binary?
Yeah.
First element of metal? Yes. Does it have more than one possible charge?
Yeah.
Yes. Now, there's a little shortcut you can do here. Look up the charge for the anion. What's the charge for oxygen? -2. Then it's kind of a shortcut. You don't have to look up all the things. Does this 2 match this number here? Yep. So what's this compound? Iron 3 oxide. Good. Because if these two match, then these two have to match, right?
So what if it doesn't match?
Well, we're going to get there in a minute. Give me 1 second on that, okay? This is rust, guys. Iron 3 oxide is rust. If I have FeO, now does that -2 match this number down here? What number is down here? A 1. These numbers don't match, do they? Well, here's what you do. If the numbers do not match, Mason, I need you sitting up, please, okay? Okay. If these two numbers don't match, what number is over here right now? A 1. If there's no number, it means there's a 1 there, right? Now, a student taught me this years ago. If these two don't match, all you got to do is multiply these two. What is 2 times 1? No charges. That's a 2 times a 1. So it's 2. So this is going to be a +2. This has been reduced. It used to be Fe2O2, but then we reduced it to FeO. We divided both sides by 2, didn't we? We'll do a couple more of these. So this is iron 2 oxide. This is black powder, part of black powder. And you know what black powder is? It's explosive. It's like gunpowder, yes. So if I said, hey guys, go heat up some iron oxide. Well, either you go get the iron 3 oxide, which will not explode in your face, or you'll go get the iron 2 oxide, which will explode in your face. So this is why I need to tell you which one you're using. Hey guys, go heat up the iron 3 oxide. That's the safer route. You just can't say iron oxide. That does not tell the person what they need to know. Does that make sense? Okay, let's do a couple more of those reducing ones. Okay. So if I have first element hydrogen? Nope. Is it binary? Yes. Is the first element a metal? Yes. Does the metal have more than one charge? Yes. And if you want to write them down up here, you can. What's lead's charges? +2 and 4. What's oxygen's charge? -2. Now the all-important question I must ask you, does this number, the superscript, or the superscript for oxygen, match the subscript down here? No. Since these two do not match, I got to multiply these two here.
4.
So this will be the +4. This used to be Pb2O4, but we reduced it down to PbO2, didn't we? We divided each of these by 2, and we got PbO2 is what we have. So this is lead 4 oxide. Does that make sense? Well, I'm sorry. So, since these two don't match, okay, then we know it's been reduced. But But it's been reduced from what? We need to know. So, if these two don't match, just multiply these two over here, and that'll tell you what it used to be. It used to be a 4 down here. This used to be a 4, and that used to be a 2. It's just been reduced down. Does that make sense? How do you feel about that? Do you want to do some more, or you want to start working on some practice stuff? Practice? I'll be around to help you, so if you're not as confident as you think you could be, I'll come and help you do this.